All right, we're going to talk about congruent polygons. So the first thing we need to do is be able to identify polygons being congruent by using corresponding parts. So I'm going to write a congruent statement for the triangles listed here, and I'm going to identify the pairs of congruent corresponding parts. In fact, I'm going to do part of this first. Okay, so first thing I'm going to do is I'm going to say, well, angle A is congruent to angle D, and we know that because they both have one arc mark in there for the angle. We also know that angle B, which has two arc marks, is congruent to angle F, and we also know that angle C is congruent to angle E because it has three arc marks. All right. So using that now I can make a congruent statement for the triangles. I could say triangle A, B, C is congruent to triangle D, F, E. Notice I used the order in which I wrote the congruent statements there. I have to make sure that the corresponding angles are in the same order on both parts here. Therefore, the first position, A, corresponds to D, B corresponds to F, and then in the third position, C corresponds to E. So that also allows me to, helps me to identify corresponding sides. So I switch colors here. I could look at this, just a statement without looking at the picture and say, well, I know then that AB, length AB or side AB is congruent to side DF, because that's the order in which we see those letters in those positions. I know that side AC is congruent to side DE. I'll make sure that this isn't confused with an E there. There we go. And then that side BC is congruent to side FE. And then you can check it. I mean, notice that AB and DF both have two markings. Notice AC and DE both have one marking. And BC and FE both have three markings. All right. So that's how you can, you have your congruent corresponding parts, and then you have your congruent statement right there. All right. So now using that, especially the order piece, I'm going to look at this diagram. ABCD is congruent to QRST, and notice A corresponds to Q, B has to correspond to R, C to S, D to T. So I'm going to use that to find the values of X, Y. So what I can look at is just first I need to find X, Y. Well, there's X. There's X and Y. Okay, well, I'm going to take this, 3X minus 5, and that represents side CD. So actually, let me write the CD first. CD, which is 3X minus 5. And I know that CD is congruent to ST, because that's the order in which they're given. So if I look at ST over here, ST has a length of 25. So CD and ST, they're going to be equal, meaning that this is 25. Okay, so if I substitute 3X minus 5 in for CD, 25 for ST, and then solve that, I get 3X equals 30, and 1X is 10. Okay. Now I can also look at this value right here. I know that angle S is where 4X plus 3Y is. And I know that angle S corresponds to angle C, which is 79. So the measure of S, I guess that's actually the measure of S, is equal to the measure of C. So if I substitute 79 in for C, 4X plus 3Y for S, and then I substitute that 10 in for the X, and then solve here, it's 40 plus 3Y equals 79. 3y equals 39, that means 1y is equal to 13. All right, so x is 10, y is 13. So that order in which they're given really helps out there. We're going to talk about some properties, triangle congruence. First, the reflexive property for triangles. For any triangle, triangle ABC, that means ABC is going to be congruent to itself. That's what the reflexive property says. Okay. Symmetric property, if ABC is congruent to DEF, then triangle DEF is going to be congruent to triangle ABC. Reflexive, or the symmetric property is almost like the commutative property there. You just switch them around. And then remember the transitive property, if ABC is congruent to DEF and DEF to JKL, then we kind of eliminate the middle piece and say ABC is congruent to JKL. All right. And then the last theorem here, or property, I guess, well, this is a theorem, but the last one we're going to deal with, third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, so for instance, A being congruent to D, B congruent to, say, E, that would mean the third angles. That's supposed to be an angle symbol, but my pen botched up there, are congruent. So the third angles then would have to be congruent. So if I put some measures in, say like this was 60, this was 80, okay, and that would be 140, which would make this 40. So this would be 60, because they're congruent. This would be 80, which would also make this 40. Okay, that's how that works. So if 60 and 80 are congruent, the last one in both triangles have to be 40. All right, so using that third angles theorem, what we could do is we could look at a picture like this, where we have A congruent to D, E, and B congruent, and we're trying to find F. Well, we know that if 46 and 85 and angle C have to equal 180 degrees, that would then tell us, well, 46 and 85, first of all, that's 131. And it tells us the measure of angle C is 49. So if this is 49, based on the third angles theorem, this angle F also has to be 49 degrees. So the measure of angle F is equal to the measure of angle C, which is equal to 49 degrees. All right, there we go. That's all I got for you. Good lucky.